frame always contains an MAC address. It is therefore possible to find the IP address associated with the MAC address. For example, when pinged, the MAC address associated with the ping IP address is included in the destination MAC address field of the frame. To find an MAC address from an IP, we use a Layer 2 protocol, which is called ARP. ARP provides two services. It allows you to make an address resolution. That is, it maps IP addresses that correspond to MAC addresses. And it stores locally the MAC addresses that are learned by this protocol. To find an MAC address, ARP sends a message in the broadcast to all devices in the same network. This message includes its own IP address and destination IP address. The device that recognizes itself then responds with its own MAC address. And upon receiving this response, the sender updates its correspondence table. ARP is a Layer 2 protocol, which means that its scope is limited to the local LAN. We will now see how it works to solve an MAC address of an IP address belonging to the same network. On this topology, we have two subnetworks. The left subnetwork is the 192.168.1.0 with a mask in /24, 3 times 255.0. And on the right, we have the 192.168.2.0 with the same mask. Let's say that the PC, which has just been started, and therefore its ARP table is empty, wants to know the MAC address of the IP of the printer to start a communication. As it does not know it, it will broadcast a broadcast on all devices of the same subnetwork to ask who belongs to the IP 192.168.1.2.0. The printer, which recognizes itself, will respond with a unicast frame, indicating its MAC address. Now what if the PC wants to communicate with a device that is not part of the same subnetwork? For example, with the server. Well, thanks to the subnetwork mask, it will immediately see that the server is not part of its own network. It will therefore send the data directly to the default gateway. That is to say, the interface of the router that carries the IP in .254. The default gateway, also known as gateway, is set up directly on the PC. As the PC has just been started, it also does not know the MAC address of its gateway. So it's going to send again a broadcast to find it, and the router will respond directly with a unicast frame. It is therefore the router which will carry out the communication between the two subnetworks. If the PC wants to communicate with the server, its IP header will contain the IP address of the server in the field of the destination IP, and the router's MAC address in the field of the destination address MAC. Each IP device keeps a table in memory. It's the ARP table. The purpose of this table is to cache IP addresses and MAC addresses. The ARP-A command displays the ARP table. In the command, we do it on the PC. When a host wants to pass data onto another on the same network, they search the P table to see if there is a match. If there is an entry, it will be used. If there is no entry, the IP host will send a broadcast ARP resolution request. The fact that you can cache this IP MAC match reduces ARP queries in broadcast. Because without the ARP cache, each host should send a broadcast every time they want to communicate with another. At the exit of the ARP-A command, we see that it is very easy to locate the match between the IP address and the MAC address. This table is held dynamically on every device in the network. These entries expire after 300 seconds. That's the default. This very short delay allows you to have a table with very little information out of date. If no device responds to an ARP query, then the package will be deleted. Because an entry into the table cannot be created without the destination MAC address, And to display the ARP table on a router, you have to use the showIP ARP command. It is even possible to limit the output with options like IP addresses, host name, MAC address, or interface type. The PC is able to communicate directly with the printer because they are on the same network. On the other hand, if the PC wants to communicate with the server, which is not part of the same network, then it will have to send the data directly to its default gateway, the gateway, and it will be responsible for transferring the data to the server. The default gateway is required to send a package off the local network. As the network part of the server address is different from the PC network, then the package must be routed outside the original network. It must be sent to the gateway by default. The gateway is a router interface connected to the local network, and this interface carries an IP that corresponds to the subnetwork to which it belongs.